Hi, I'm Dan Herbert, course developer and instructor at Point Blank, and this tutorial video gives you a flavour of what you can expect on our online courses. If you want to develop your music production skills further, head to www.pointblankmusicschool.com to find out more about this course, plus many more that we offer in London, Los Angeles, Ibiza and online. Over the course of this tutorial series, we're going to take a look at Arturia's ARP 2600 V3 and also the Moog Modular. This first video is an overview of the ARP 2600, and in the following video we'll then explain how to recreate these synth sounds. So the ARP 2600 was a classic semi-modular synth and was first released in 1972. It was used by musicians such as Stevie Wonder, Joe Zawinul from Weather Report, Jean-Michel Jarre and Herbie Hancock to name a few. And it's a great synth to learn the principles of modular synthesis on, as it's not too complex but offers loads of creative potential. It's fundamentally a 3-oscillator synth, VCO1, VCO2, VCO3 with a filter section here, amp section, and main output, which also includes a simple reverb. In addition, it offers two envelopes, an ADSR envelope and an AR or tack release envelope. There's a standard LFO down here which is syncable to your DAW, but the oscillators can also be used in low frequency mode, giving you some more options there. Underneath each section you find a row of faders, and some of these will allow you to mix the audio sources together, or in some cases also combine some of the control signals together. Down here we have a noise generator. In the middle section here we've got a voltage processor which allows us to combine, mix and process signals in a number of different ways. And then to the right here we have the sample and hold section, as well as an electro switch, which essentially allows you to flip between different signals. Hiding either side is not something which was included in the original, but we've got here a chorus and a delay unit, and then on the right hand side there is the tracking LFOs, which gives you 4 additional LFOs, which again can be synced to your host DAW, and you can create your own custom waveforms as modulation sources. Up in this top left hand corner we have an external input, so we can actually process incoming audio through the filters, for example, and there's also an envelope follower here, so we could use the dynamics of any signal coming in to modulate any of the specific parameters. In addition, we've also got a ring modulator here, so again we could process incoming audio or actually to combine the outputs from 2 oscillators. Lower down, if I just scroll down here, you can see the step sequencer here, which is basically a 16-step sequencer, or you can also use it as 2 8-step sequencers. And then below that we have the keyboard and various parameters over here, such as portamento. Up here we've got the global section, so we can tune it globally or also switch from monophonic to polyphonic. So one of the great things about the ARP 2600 is there are a number of internal connections, which means you can easily get a sound out without patching in any cables. So what I'm going to do first is come down to the preset template, and let's just choose 1 OSC square. So if I play the keyboard, we've got a square wave, and as you can see there are no cables patched in. What I'm also going to do is go to the resize window and choose 90%. So it fills my screen. I find myself constantly coming back to this menu. It'd be great if there was actually shortcuts for this, but yeah, we kind of toggle between the different screen sizes. So let's take a look at the signal path. So the sound we can hear is the square wave, and that's coming from VCO1. There's an internal connection which goes from VCO1 all the way along here into the filter section. So you can see here VCO1 and indicates a square wave. So although we've only got 3 oscillators, actually they generate 10 waveforms simultaneously. So saw, square, triangle, saw, sine, pulse, you get the idea. So the sound from oscillator 1 is hardwired, routed through to the filter section here, and that in turn is routed into the VCA. Okay, and at the moment when I play a note, the envelope is actually triggering the VCA, and then it goes to the output section. Equally, we could come along here and let's just turn up VCO3. Okay, and add in VCO2 as well. And the parameters for each oscillator are fairly similar. Okay, so we've got an octave setting. and you can also set the semitones differently as well. Whenever you're setting parameters, it's always handy just to keep an eye down this bottom left hand corner, because it gives you a much clearer indication of your semitone settings. You also got a fine tune control here, so it's handy for doing detune type sounds. And to reset any of these controls, just double click and it resets them to their default values. So the filter is a multi-mode filter, and you can just use this switch to switch between the different filter types, and the cutoff can be adjusted through this slider. You've also got a fine tune, and depending on where your filter is set is how obvious that will be. Obviously resonance. Okay, and with high resonance settings, when you've got the 24 dB per octave low pass filter set, it will actually self-oscillate. And the next section we have here is the envelope section. So the ADSR is hardwired through to the filter as well as the 3 oscillators. So if we push this up fully, just drop the cutoff down. Okay, and if I turn that down, there's no envelope modulation. Or if we do this to the oscillators, let's just open that filter up again. You can hear the envelope is now modulating VCO1. The AR, attack release envelope, is currently modulating the VCA. So if I turn that down and I press the key, we don't get any sound out. And we can equally switch that between linear or exponential. Basically, you get a slightly different response. You'll find exponential gives you a slightly tighter response to the envelopes. In the output section, we can actually bypass the VCA, and this can be quite useful for when you're kind of designing sounds, so you don't have to keep triggering your keyboard. I mentioned about the reverb earlier. This used to be a spring reverb originally. There we go. Let's turn that back down and take that off. So let's look at some modulation options now. I'm just going to reset the preset and resize the window. And what I'm going to do is route the square wave from the LFO, which is this fella here, into the FM control of oscillator 1. And the other thing I'm just going to do is just disconnect the mod wheel and turn down the vibrato depth. And let's just turn up this fader here, so we hear the sound without me having to play the keyboard. And now I'm just going to increase the modulation amount here. Okay, so this is modulating VCO1 with a square LFO. We can change the rate of this LFO just by grabbing the LFO speed. Okay, now we get some chiptune kind of sounds going on. Any section which has some form of clock on it, like the LFO, you'll typically find a little MIDI button here. Okay, so look down this bottom left hand corner. As I'm adjusting that, that's in Hertz, switch it to MIDI, and then it gives you a tempo value. This is actually related to a quarter note beat. Okay, so when it's at 1, then that should be a quarter note LFO. And it'll be synced to your DAW, that'll be an 8th note or whatever. On the original ARP 2600, the VCOs doubled up as LFOs as well. So if I just disconnect this cable here, and you'll see this input here is VCO2, and it's got an icon indicating a sine wave. Let's just turn up this fader again. So what I'm going to do is switch this to VCO2 to low frequency mode. Okay, so depending on the frequency or speed of VCO2, it's now modulating the pitch of VCO1 as I speed it up. And now we move into the realms of frequency modulation and all the wonderful sounds we can get out of FM synthesis. It's kind of metallic, noise-based textures. Brilliant. Let's turn that down. So let's now look at the sample and hold module. Again, we don't need to patch any cables in as it has its own built-in clock. It's basically a square LFO, and it automatically samples the noise generator. Okay, this is the noise generator over here. So what I'm going to do is going to turn up the filter on that, and also importantly the level. Okay, the sample and hold module comes in here. So again, let's turn this up. Can't hear anything happening at the moment, so I need to turn this fader up. So what's happening is essentially we've got this clock here, which causes it to sample or measure whatever level the noise is at. Okay, and then that's routed through to the pitch of VCO1, and we're getting these basically random pitches. Speed up the rate. Brilliant. And then slow it down. So if we want something perhaps a bit more musical, then instead of sampling noise, what we could do is sample an LFO. Okay, so let's choose the sawtooth over here, and we're going to connect it into this inlet here. And alright. Now the important thing when we're doing this is the relationship between the different rates. So if I slow this down and speed up the rate, you can hear we're getting these kind of notes cascading down. And now if I speed this one up, again we can get kind of chiptune effects by using high rates values, or we can get these kind of varying melodic patterns. Now what you might notice is these don't exactly sound in tune, okay, and that's because it's just sampling a continuous controlling voltage. What we can do, however, is use the Quantize section over here. So let's go from the sample and hold out into the input here, and then from the quantized out, and we'll just drop it straight into here. So now we're getting specific melodies. If it's too, we can just reduce the level. Just small adjustments can have quite a significant effect. The other useful thing we could do as well is actually use this clock from the sample and hold to trigger the AR envelope. Just need to switch this down here. Just turn it down a bit. Okay, so now that's going to be in time with whatever rate we choose there. So watch out for the next video in this series when we'll check out some of the other features such as the step sequencer and focus more on creating some specific sounds.